Lean-on bracing applications are being used at a greater rate in steel bridge systems. This has highlighted a need for improved rules of configuration and design expressions. The Center for Transportation Research, the Texas A&M Transportation Institute, and the Texas Department of Transportation monitored a recently designed bridge with lean-on bracing to come up with guidelines for bracing design and improve accuracy in stiffness and strength components.
If you've ever gone underneath a steel bridge, you may have noticed these X's underneath, steel cross frames underneath. The function of those is for stability, primarily during construction, to keep the girders from buckling. However, because they're these cross frames and they're welded together and they're hard to fit up, they look small as compared to a bridge, but compared to a man trying to put it up there, they're quite heavy. So this lean-on bracing concept removes a lot of the diagonals, simplifying the construction and fabrication dramatically. However, the cross frames that you were removing were doing something before. So now there has to be a new design methodology to make sure that the cross frames that you do have are sized appropriately and then also placed throughout the structure appropriately so that you still have the stability that you need.
What happens with cross frames and diaphragms is that there are regions where there's usually concerns about fatigue. And also when we have cross frames and diaphragms, they usually represent one of the most expensive components on a per pound basis because there's lots of fabrication associated with them. So in lean-on bracing, what we did 20 years ago is we developed a concept where we were able to selectively go into a bridge and eliminate some of these full cross frames and instead just make use of some much more simple, we call them lean-on struts that allow several girders to lean on a single cross frame. And while some of the suggestions we had done and the systems we had designed 20 years ago, they started to be implemented into design, it was found that we probably left too much of it for interpretation by a designer, where some designers were having a hard time applying some of those concepts, and a number of questions came up. So to try to get in on those design concepts we developed 20 years ago and really try to develop some refined procedures that make it easier for designers to apply, but also try to answer some of the questions and so on that came up.
The benefits of this project really stem from the fact that cross frames are some of the most expensive components on a steel bridge. Though they are obviously essential, they're difficult to fabricate, difficult to install. They're also difficult to inspect and can have trouble spots in them. So being able to safely reduce the number of these cross frames really leads to a more economical structure, both in the short term and long term.
And then over the last 6 years, there have been some applications where TxDOT has essentially utilized these methods on the design of a few different bridges. One was up in Fort Worth, which was a heavily skewed bridge, which is just a geometrical configuration that happens with the bridge. Then we had a bridge over the Brazos River that had normal support. So it's been used on a couple of different geometries. So it's already starting in an implementation, but these concepts actually are seeing a lot more widespread usage because the National Steel Bridge Alliance has been pushing these concepts, and there was a design guide that was based upon our original work that was put out. So we're going to start seeing a lot more applications of these, not just within Texas, but actually around the country.
We plan to take the findings of the report and put it directly into our design guidance so that engineers can use it readily and quickly.
For more information and to find the publication for this project, please visit the TxDOT Research Library at the link shown below.